Hi everyone, this is Alex Gerard and Michael Baumer, and we are PCIe test engineers at the University of New Hampshire's Interoperability Lab, and this is our presentation on transmitter and receiver conformance testing with OCP NIC 3.0.
Since 1988, the UNH Interoperability Laboratory has enabled multi-vendor interoperability through conformance testing and developing custom testing solutions while preparing students for careers within the computer and engineering industries. Over the years, we have grown steadily into one of the premier independent labs for new technologies, allowing us to become a thought leader within the data and networking world. Recently, we have been working on developing full testing capabilities for OCP NIC 3.0. in preparation for OCP NIC 3.0 certification program. This technology and certification program will be essential to improving hyperscale data centers and HPC deployment. The topics we will be covering today is why is OCP NIC 3.0 TX-RX conformance testing important? What does our testing setup look like? S parameters for PCI SIG and OCP NIC 3.0 boards, current test plans and availability, and the call to action.
Why is transmitter and receiver conformance testing important? So it helps guarantee baseline electrical compliance among the NICs, which should guarantee a high level of vendor interoperability from the start. This is especially important in the development phase when cards are brought to PlugFest and tested against many other vendor systems. If vendor interoperability problems do arise in that scenario, it helps narrow down the possible cause by removing something from the physical layer as being a problem in the system. Finally, it helps give purchasing companies confidence that an OCP NIC 3.0 card that they buy will work right for the first time and every time in their server to fulfill their needs. So what does our testing setup look like? The compliance baseboards and load boards that we use in our testing are the Dell-designed ones that we have produced for both us and other member companies, and the files for them can be found on the working group site. On the left you can see the compliance baseboard with its various sections labeled, and on the right is the compliance load board used in receiver testing to calibrate the stressed eye. In the middle is a picture of our full transmitter testing setup, which is very similar to a normal PCIe transmitter testing setup. The NIC is first powered on and begins transmitting at Gen 1 speed. It's then cycled through all waveform presets for each active lane and all supported speeds, being tested for each to ensure it meets the PCIe standard. Not pictured is our receiver setup, which again is very similar to a PCIe receiver setup. The compliance load board is first used to calibrate the worst case stressed eye signal that the NIC must pass data through at. We use an Enritsu MP1900 as both a waveform generator and error detector, with the NIC and compliance baseboard in between. Once the eye is calibrated, the PCIe signal is sent from the MP1900 to the card, and then the card transmits back again into the error detector. Now I'd like to talk about the S parameters and loss values for the PCI SIG CBB and CLB versus the OCP NIC 3.0 CBB and CLB that we use in our testing. For the insertion loss, you can see that both mated pair boards are very similar up until around 2.5 GHz, or the speed of Gen 1 PCIe. Past that, the OCP NIC mated pair has better insertion loss than the PCI SIG mated pair. This means that the OCP NIC mated pair will not introduce any extra insertion loss that is not already deemed acceptable by the PCI SIG boards. For the return loss, the values between both mated pairs are very similar all throughout the frequency range of 0 to 20 GHz, ensuring that the OCP NIC mated pair meets the electrical standards that the PCI SIG 3.0 mated pair does as well. The following is the current test plans and availability for NIC 3.0 at the UNH IOL. We offer full on-site testing of Gen 3 and Gen 4 transmitter, complete with full test plans specific to OCP NIC 3.0. We also offer Gen 3 and Gen 4 receiver testing with NIC 3.0 specific test plans a work in progress. All of our Gen 3 and Gen 4 OCP NIC 3.0 CBBs and CLBs have been created by us and are available to purchase if you would like to perform the testing on your own at the link provided. Finally, I'd like to say a thank you to Intel and Mellanox for providing us OCP NIC DUTs to aid in our test plan development.
Implementers should be following the OCP NIC 3.0 subgroup project for 2020 updates via the mailing list, which can be found at ocp-all.groups.io/ocpnic. The subgroup wiki can be found at www.opencompute.org. Implementers can check for compliance test fixtures at www.iol.unh.edu/solutions/testtools/ocp-bcie. Future OCP NIC 3.0 Interop Plugfest dates are still to be determined.